5.6. Inequalities in one triangle. The triangle inequality theorem states that the sum of any two sides of a triangle must be larger than the length of the third side. So number 1, can a triangle have sides with the given lengths? So we have 1, 2, and 4. So add up the two smaller sides, that's 1 and 2, you get 3. 3 is smaller than 4, so it will be no. The sum would have had to have been larger than 4 to satisfy the triangle inequality theorem. So we're going to say C. And that's number 1. Number 2, explain why the measure of angle 1 is greater than the measure of angle 2. First, what statement below can be made? Since it's talking about the triangle exterior angle theorem, that says that the measure of angle 1 equals the sum of the measures of angles 3 and 4. So that means the measure of angle 1 has to be greater than angle 3 and greater than angle 4. Now angles 4 and 2 are alternating interior angles, which means the measure of angle 4 is equal to the measure of angle 2. So the measure of angle 1 is greater than the measure of angle 2 by the substitution property. And that's number 2. Number 3, list the angles of the triangle in order from smallest to largest. Now the smallest angle is going to be across from the smallest side, and the second smallest angle will be across from the second smallest side, and the largest angle will be across from the largest side. So that means that the smallest angle is K because it's across from the smallest side. So you go from K, the second smallest side is 4.6, which is across from L, so then K, L, and M. So K, L, and M, C for number 3. Now number 5, we are doing the reverse and listing the sides of the triangle in order from shortest to longest. So we're doing sides instead of angles. Finding that third angle first, we add these two up and subtract from 180, and we get 54. So the smallest side will be across from N, which is OM. The next smallest will be NO, followed by NM. So we will choose A, which is number 5. Number 6, a triangle has sides of length 3 centimeters and 9 centimeters. What can you say about the length of the third side? So all you do here is add up 3 and 9, and you get 12, so that means it has to be smaller than 12. Then you subtract 9 and 3, and you get 6, so it means it has to be larger than 6. So that means it has to be larger or longer than 6, but shorter than 12. So that means it has to be choice G, and that's number 6. Number 7, determine which segment is shortest in the diagram. Okay, so the first thing we need to do is find this angle and this angle. Because remember, smallest sides across from the smallest angle. So finding this angle, add these two up and subtract from 180, you get 81. Add these two up and subtract from 180, you get 43. Okay, so looking at each triangle, the smallest side of this triangle is going to be this one because it's across from the smallest angle of 38. This side is part of this triangle. The smallest side of this triangle is going to be this one. So this one actually has to be smaller than this one. So we're going to say BC. And that's number 7.